So, okay, my dear students, today we will going to start with the module 4, right? So, module 3, we covered first part of the module 3, second part we will discuss later. Second part, only all theoretical concepts are there. So, I will going to discuss those things later. So, now I will let me complete the module 4. So, if I complete one question at least from each module, it will be easy for you to prepare for your exam. Okay. So basically, module 4, we have two different parts. The first part is completely for the design for that is manufacturing aspects for optimization problems. So, so generally from past to the last 1 year or 2 years, last time I think they had given one problem on this manufacturing problems on optimization also. So we will check how, but I don't know where they have got this. So I'm just getting that how to solve those problems and get the number of problems on that manufacturability and optimization problems. But theoretical concepts we're going to discuss and we're going to complete it. And later part I will going to take it for some numerical problems on this. Okay. So the first part is basically a manufacturability in the manufacturability in optimization problems, right? And the second part is the design interpretation. So design interpretation in the sense, so how we'll go into interpret if the solutions are having a different aspects. So if the solution is an unbounded solution, if we have a multiple solutions for the same problem, okay. So if it is you have any what do you call it as constraint, what do you call it as screening. So like that, there are so many aspects are there for how we can interpret the designs, right? So this is the second part of the problem what we have. So first we're going to start with the first part of the module 4, which we have manufacturability in optimization. Okay. So in that aspect, so we are going to discuss the concepts now. So what are the concepts of to be discussed in that manufacturability? So we're going to have it done. Okay. And later part, we will going to have later part, we will going to solve one or two problems on this optimization in manufacturing also. Okay. So let us start with the concepts now, right? I think you can see the screen what I have been displaying over there. So, would you able to see everybody?
Yes, sir.
Yeah. So manufacturability in optimization problems and design interpretation. So this is the module 4. Okay. So under this module 4, so the syllabus what we're supposed to discuss, the concepts or the contents what we're supposed to discuss is the first part is design for manufacturing, manufacturing methods and rules, and applying manufacturing constraints to the optimization problems. Okay. So that is the first part of the module 4. And the second part, we need to discuss the design interpretation. So where we have to, how the problems which are having unbounded solutions and which are having a over constrained problems or problems with the number of multiple solutions and what is active and inactive constraints and how we can interpret the constraint violations and constraint screening and design limits and local and global optimum. So these are all the second part of the module 4. Okay. So let us start with the first part of the module 4, where manufacturability and optimization. So let us take the first concept in this is design for manufacturing. So we will going to discuss this design for manufacturing first in today's class. Okay. And later part, we're going to have manufacturing methods, rules, and constraints, how we can use these manufacturing aspects in our optimization problems. Okay. So in that respect, today I will be starting with the first part of the module 4, which is design for manufacturing. So of course, you have one subject in your third semester, design for manufacturing and assembly, but they have added this also in your syllabus in the design optimization. So let me discuss this in brief, but where there we will going to discuss in detail in your third semester. Okay. Yeah. So design for manufacturing. So I think you might have discussed design, you might have defined design, and you might have done so many problems and solutions you might have obtained in your undergraduate program, and as well as in some of the courses in master's program also, right? So design where you have studied is basically based upon the strength or based upon the rigidity. So you generally you use the what you call it as the failure criteria to design the components or design the elements, the machine elements. So based upon the strength and based upon the rigidity. So these are all what we have, what you have done. It is for to obtain the failure analysis. So ultimately, the design is to make the components which are safe, right? So when you say safe, so it does not undergo any failure. That is the one main objective what we are having. So based upon the safety of the components, so you might have used different aspects of obtaining the cross sections or whatever it might be for the given component, and you will go to say the design is safe. So all those concepts are basically it is designing elements, right? So now what we are moving towards is design for manufacturing. See, once you design a component, so we're going to say this is the diagram. So we're going to give the dimensions of the components based upon the design what we have done, right? So once it has been designed, it needs to be manufactured and it needs to be assembled at the head. So then only it will get a final form of a product, right? So now, once the components are designed for their dimensions, now it needs to be manufactured. Okay, so what you have done is till now we are into the undergraduate program is designing the components for their dimensions. You know how to design or how design and draw. So once you design the dimensions, and the same thing you can draw with the two-dimensional software or three-dimensional solid modeling, you can do and you can get the components. But when it actually comes into the manufacturing, so the components, so what we go one step ahead is how we can design a components for its manufacturing and how it can be designed for assembly. Okay. So when you have visited any industries or any companies, so you might have seen, you might have observed many things. So many things in the sense, so there are so many concepts they might have been implemented, so many steps they might have been following, so that where they ultimately what is their aim is to minimize the time or minimize the cost, whatever it may be. Also, ultimately everything leads to the cost aspects, right? So therefore, even in whether you design for a manufacture or design for elements or design for assembly, ultimately what we are aiming is minimizing the cost. So minimizing the cost. So that is the most important thing for any of a design engineer. So it is not only designing the components for its dimensions, so we need to design it for manufacturing, also for assembly. So in that respect, so today we will going to start with the design for manufacturing, and also I will just introduce some more concepts on design for assembly also, even though it is not there in the syllabus. So I wanted to include that also in your board here. Okay, so yeah, so this is what you are seeing on your screen. Design for manufacturing. The definition is given over there. A DFM is a method of design for ease of manufacturing of the collection of parts that will form the product after assembly. It is a method of design for ease of manufacturing of the collection of parts. In the sense, how easily we can manufacture the different parts which will going to form a product after assembly. So for that we need to design. So what are the different manufacturing methods it has to undergo? So what are the parameters that needs to be considered while you are manufacturing? So So what are the safety precautions? So there are so many plenty of aspects are there when it comes to the concept of manufacturing, right? So in that respect, so we need to have a set of guidelines, set of rules, what we can call it as set of guidelines. So where we can design or where we can manufacture the collection of parts that will form a product within ease. So when it comes to an ease means ultimately it leads to the final objective of minimization of the cost. So a DFM is a one such method where you can design the ease of manufacturing of the collection of parts that will form the product after assembly. So in one word or one simple sentence, we can say optimization of the manufacturing process. Optimization of the manufacturing process. That is what design for manufacturing. So when it comes to the optimization means what? So we need to achieve the objective function. So what is the objective function especially? It is the minimization of the cost. So optimization of the manufacturing process is nothing but the design for manufacturing, right? So basically, it is a set of guidelines that everybody should follow. Means in the sense the company which will go to implement that is DFM. So they need to follow a set of guidelines when they are manufacturing the parts. Manufacturing the parts. So that what are those guidelines and how we can implement the design for manufacturing in the companies and how beneficial this DFM for the companies in achieving their minimization of the cost. There are plenty of aspects that need to be discussed over here. Okay. So in one sentence, in a simple sentence, design for manufacturing is nothing but optimization of the manufacturing process. In a similar way, we have a DFA is a tool. So DFA means DFA stands for Design for Assembly. Design for Assembly is a tool used to select the most cost-effective material and the process to be used in the production in the early stages of the product design. Okay. So in the picture, what we have seen here, it is just like a one manifold over here. So you can have a plenty of, there are a collection of parts. So once each parts are manufactured separately and it will be assembled. So once it has been assembled, then it will form a product. Okay. So when you are manufacturing various parts, a collection of parts, so we need to follow a set of guidelines, as well as when you are assembling the parts to form a product, we need to follow certain guidelines. So when you are manufacturing, the guidelines what to follow, that is nothing but the design for manufacturing. And when you are assembling, what the guidelines you will go to follow, that is nothing but the design for assembly. So these two, design for manufacturing and design for assembly, so put together. So nowadays we are using the term as design for manufacturing and assembly. So DFMA. DFMA. So this is the one what we're going to have in the one course is there in you for third semester of your PG. So we're going to discuss those things in details when it comes for third semester, right? So here only just the guidelines I'm giving over here. So please just have only an introduction to the DFM. DFA is not there. DFM only, it is been specified in your syllabus. So please stick on to the DFM. But when and where I just want to add DFA, I will going to just add the DFA also. Okay. Yeah. Let us move on to the major DFM objectives. So what is the objectives of DFM? The major, we can put it as a major. So first one is estimate the manufacturing cost, reduce the cost of the components, reduce the costs of assembly, reduce the costs of supporting production, consider the impact of DFM decisions on other factors. So this is the main DFM objectives we are having. So first one is we need to estimate the manufacturing cost. So manufacturing cost means there are plenty of cost that will come into the pictures. So when it comes to the manufacturing, it is a raw material cost, inspection cost, machining cost, human labor cost, and then what you call it as tool cost, everything put together, and one sometimes we get overhead cost, maintenance cost, so everything. So all these things put together, we call it as a manufacturing cost. Okay. And second important thing is reduce the costs of the components. So how do you reduce the costs of the components? Through selecting and optimized materials. Optimized materials, selection of optimized materials, where it can also leads to the optimization of the selection of tools also. So because once you select the material which is very optimized, then everything, the cost which are related to the other aspects will also get optimized. So this is, we need to reduce the cost of the component, reduce the costs of assembly also. Okay. So how do we reduce the cost? Means is the number of components if you start reducing, so automatically the cost of the components will get reduced and the cost of assembly will also get reduced. And reduce the cost of supporting production. So other apart from the major, so is there any part we need to support? We need to have just like a washer or what we call it as the sealants, whatever it might be. So that this also may be required for us to have it in our components in our assembly. So there that will constitutes a supporting production. Consider the impact of DFM decisions on other factors. So if we implement the DFM, okay, so during the DFM implementations, we might have made so many decisions. So what should be the impact of DFM decisions on the other factors? So these are the 5 major DFM objectives what we are having. Okay. So we will have a definition of design for assembly also. So DFA or DS design for assembly is the method of design of the product for ease of assembly. So where the ease of manufacturing is relates to the manufacturing. So ease of assembly is for a design for assembly. So here we can put it in a simple words: optimization of the part or a system assembly. Okay. So a tool is used, DFA tool is used to assist the design teams in the design of products that will transition to the productions at a minimum cost, focusing on the number of parts, handling, and ease of assembly. So in the sense, we have a certain tool, DFA tool is there. So this tool, it will go into assist the design times in the design of products that will transition to productions at minimum cost. Minimum cost, you are producing the parts or the components at the minimum cost. And most important thing is it will focuses on the number of parts. So if you keep on reducing the number of parts, automatically the time required, the cost required, everything will get reduced. And the third important thing is handling. So how we will going to handle the components and how we can easily assemble these components. This is what the DFA tool will go to help us or assist the design teams. Okay. Yeah, let me quickly have the differences between design for assembly and design for manufacturing. Okay, so both are used in the manufacturing here. Yeah, both what we are using here is a DFMA and DFM and DFA. So both are majorly concerned with the reducing the product assembly cost. So DFA is majorly concerned only with the reducing the product assembly cost. So by minimizing the number of assembly operations, and individual parts tend to be more complex in design. So this is what we generally have it in our DFA. When it comes to the DFM, so it is concerned with the reducing overall part production cost minimizes complexity of manufacturing operations, uses common datum features and primary accesses. So this is a major difference between DFM and DFA. Okay. When it comes to similarities, both the DFM and DFA seeks to reduce the material, overhead, and as well as the labor cost. They both shorten the product development cycle time. Both DFM and DFA seek to utilize standards to reduce the cost. So in the sense, when the objective point of view, both will have same objectives. In the sense, both DFM and DFA, they majorly they are focusing to reduce the material, overhead, as well as the labor cost. And also, both DFM and DFA will shorten the product development cycle time, and they utilize the standards. So when you start using standards, it will reduce the cost. So this is the same. Both will have implement all these things, and they will have an effect over the implementation of both the DFA and DFMA. So it comes to the sequence of analysis. Concept design. So you'll have a conceptual designs. Next we have design for assembly, and then we will have design for manufacturing. After doing that, then only we will going to have a detailed design. So when we had discussed the design cycle, or what we call it as design process. So once the conceptual design has been done, we might have shown the detailed design, if you remember. So now almost all the companies, they are implementing DFMA. So when it comes DFMA, or when they implement this DFMA, these are the two different processes that needs to be implemented between the conceptual design and the detailed design. So before you go to the detailed design, so the components will be designed for assembly and designed for manufacture. This is what they are showing over there. Okay, that is what the sequence of analysis we are having in this, right? And of course, we have
I will also read it. SPM
the proposed design. You can see the flow chart over here. So how we can use this DFMA for us.
So below a cube is there, on the top of the cube,
yeah,
sphere is there.
So we have a proposed design. Estimate the manufacturing cost. Once we estimate the manufacturing cost, next what we supposed to do, reduce the costs of the components, reduce the costs of the assembly, reduce the cost of the supporting production. Okay. Then all these things will lead to consider the impact of DFM decision on the other factors, recompute the manufacturing cost. If it is good enough, yes, then it will go to the acceptable design. If not, so then again you have to go for after the estimation of manufacturing cost. So this is the flow diagram, what it has been showing over here. So how the DFMA has been implemented and how the process will going to be in the case of DFMA. Okay. Yeah. Now, the design for manufacturing and design for assembly, or the integration of product design and process planning into one common activity. The goal is to design a product that is easily and economically manufactured. Okay, so DFM and DFA. So both are the integration of the product design and process planning into one common activity. So nowadays they are combining both DFM and DFA. We generally call it as a DFMA. Okay, so this will be, a common activity nowadays all the companies they are implementing. And the goal of this integration is to design the product that can be easily and economically manufactured. This is the main objective or the goal. Okay, to design a product that is easily and economically manufactured. The heart of any design for manufacturing system is a group of design principles or guidelines that are structured to help the designer reduce the cost and difficulty in manufacturing an item. The following is a list of these rules. So we will going to look out for one by one rules. What is there in that? Okay. So what are the guidelines? So why? Because they'll say so. The heart of any manufacturing design for any manufacturing system is a group of design principles or guidelines. So entire manufacturing will depend upon the principles or the guidelines. So these guidelines should be structured so that the designer structured to help the designer to reduce the cost and difficulty of manufacturing item. So when it comes to the manufacturing aspects, so there are different levels. Okay, the severity of a difficulty will depends upon what kind of features that the product have or what kind of the features that the component will going to have. So based upon that, you might be having a different the level of difficulties. So therefore, the main objective is, so once you set up guidelines, those guidelines should be structured and it should be have a proper structure. And this guideline should help the designer to reduce the cost and difficulty of manufacturing an item. So let us go to what are the list guidelines we have, what are the rules we are having in DFM. Okay, so we're going to discuss one by one now. The first important thing what they say is reduce the total number of parts. See, when we say to reduce the cost, the ultimate aim or the main objective of DFMA is to reduce the cost, whether it might be a material cost, whether it may be a overhead cost, or whether it may be a labor cost, whatever it might be. So the first important thing is we need to reduce the cost. So when it comes to when you want to reduce the cost of a material, so we need to reduce the number of parts, total number of parts. If the total number of parts has been reduced, automatically the material cost will go down. Okay, so once the material cost will go down, or if we reduce the number of parts, so the number of overheads will get less down. So what will be the labor cost? Because if the number of parts are less, the labor cost will also be less. So therefore, so first important thing is, so when you are designing any component, any product, so please design to have a minimum number of parts. That component should have, a product should have the minimum number of parts as much as possible. Okay, so this is what the first guideline or the first rule what does it says is reduce the total number of parts. The reduction of number of parts in the product is probably the best opportunity for reducing manufacturing cost. Less parts implies less purchases, inventory, handling, processing time, development time, equipment, engineering time, assembly difficulty, service inspection, testing. Look at that. So if the number of parts is less, all this, the processes what we have listed out, everything will be less. So therefore, so once you reduce the number of parts, so it will going to reduce the manufacturing cost. So that's what they listed out. If you say a less parts, what does it means? It reduces the less number of purchases, inventory will be less, handling of the parts will be reduced, processing time is reduced, development time is reduced, and the number of equipments required is reduced, engineering time, assembly difficulties, service inspection, test testing. All these processes will get reduced. Okay, so therefore, when you are designing any product, so keep it in your mind that you are designing a component for the minimum number of parts. So it means they say reduce the total number of parts. That is the first guidelines in our DFME. Okay. The second thing here is develop a modular design. The use of modules in product design simplifies the manufacturing activities such as inspection, testing, assembly, purchasing, redesign, maintenance, and service. See, modular design in the sense, so you will going to have sub-assemblies. Sub-assemblies, it is very simple here. So each part, okay, so when you're doing, so make it as if you have a product which is having an 100 parts. So out of 100 parts, if it might be having if you just disintegrate that so that you can have a smaller assemblies, just like a product which will be having 10 modules or 10 modular components. Each module will be assembled, so the risk and the ease of manufacturing the final obtaining the final product will be get reduced. So therefore, so if you just divide the total product into 10 different parts or 10 different smaller assemblies, then things will become easy for us. This is what the use of modules in a product design simplifies the manufacturing activities. So once you start implementing or using the modules, then directly it will go into eases this some of the activities, manufacturing activities such as inspection, testing, assembly, purchasing, redesign, maintenance, and service. This is another one second to this. Always try to develop a modular design. Got it?
Completed now. We understood now. Okay, yes, today.
Next one is
after demonstration will be going on for different problems.
Yeah. Use of standard components. Use of standard components in the sense.
Further, I will solve on the board remaining.
So the components which are already available in the market, which has been universally acceptable anywhere in the world. So when you just start using that kind of components, these components are relatively less expensive than that of the custom-made items. So you might be having a different idea, different plan to get a different components, but definitely it leads to the cost always. Therefore, always try to use the components which are already existing, so which might have been manufactured for the different standards and which has been universally acceptable worldwide. So this is why I'm talking this is, so when you use such type of components, so those components always will be less. So when the each component cost is being reduced, so that always leads to the minimization of the total cost of the product. So therefore, so please try to use the standard components and then that of the custom made items. The high availability of these components reduces the product lead times. Look at here. See, if you want to manufacture a single components of your own design or of your own institutions, so you have to keep the entire product in idle until that product has been manufactured and it is being used. Instead of that, when we use a components which are being standard and it's already available in the market, so take it, purchase it, and just use it and just dispatch it. So definitely it will reduces your product development time. Development time will be reduced. When the time is reduced, automatically the cost will also get reduced. And also, once the product has been dispatched into the market, so of course, if any problems are there by the customer, so he can get these parts, standard parts. If you're used, definitely it will be available anywhere and you can use it. If the components what you are used for that product is an customized one, then it is again difficult for him to get the spare parts. That's the reason why always better to use the standard components in the products. This is a third guideline. And the fourth important thing is design parts to be multifunctional. Multifunctional parts reduces the total number of parts in a design, thus obtaining the benefits given in the rule 1. Some examples are a part to act as both an electric conductor and as a structural member, or as a heat dissipating element and a structural member. In the sense, the parts what you're using to obtain the final product, let it be function. It can have or it can function not only single function it performs, let it functions 2 or 3 functions. Then it will be easy for us to, so because you are reducing the number of parts. So multifunctional parts reduces the total number of parts in the design. Okay, so you have to choose the components in such a way that the materials in such a way that so it performs not only a single function. Apart from that, simple example they have given: select a material, select a part or a part to act as both electric conductor and a structural member. Means it will go into support and it act as an electrical conductor. See, it is conducting, it is doing 2 functions over here. A single component is multifunctional, or as a heat dissipating element and a structural member. So it also acts as a heat dissipator and as also structural member like that. So you need to design a part so that it can function more than one. Means it can be a multifunctional parts. So such kind of parts needs to be designed in our DFM. This is what the rule number 4 or the guideline says: design parts to be multifunctional always. Okay. Next comes design parts for multi-use. In a manufacturing firm, different products can share parts that have been designed for multi-use. These parts can have the same or a different functions when used in different products. In order to do this, it is necessary to identify the parts that are suitable for multi-use. For example, all the parts used in the firm can be sorted into 2 groups. First, the first containing all the parts that are used commonly in all the products. In the sense, so a company might be manufacturing the different products. So one important thing what we have to design the products is what is the material or what is the components which are being already used in the firm or in the company. Okay, so you have to design. If you are designing a new product, so you should keep all these things in your mind. So what are the parts or what are the smaller elements that is available in our firm? Why don't we use that? So why? Because so when you are getting the components, when you are purchasing the components, you can purchase it in a bulk instead of purchasing it in a separate orders. So bulk purchase will always reduces the cost. So the same material is used for some other purpose in the different product, and it will go into function in a different way in your product. So this is what we have to design the parts which can be used for multi-purposes. So this is what a different products can share parts that have been designed for multi-use. These parts can have the same or different functions when used in different products. In order to do this, it is necessary to identify the parts that are suitable for multi-use. So first important thing is you have to identify which are those parts. Once you identify, then we can use those parts for in different components where it can serve for different purposes. So this is the next guideline what we are having. Next one is design for ease of fabrication. Select the optimum combination between the material and the fabrication processes to minimize the overall manufacturing cost. In general, final operations such as painting, polishing, finish machining, etc. should be avoided. Excessive tolerance, high surface finish requirement, and so on are commonly found problems that results in higher than the necessary production cost. So what they're saying here is, so when you're designing a component, so design it for ease for fabrication. So for that, you need to select the optimum combination between the material and the fabrication process, which minimizes the overall fabrication or manufacturing costs. Simple example, final operations such as painting, polishing, finish machining should be avoided. So it's not necessary. So you have to select the product or the material in such a way that so you can avoid the painting, you can avoid the polishing, you can avoid the finish machining. Means you have to trade off, means you have to select in such a way that the material and the fabrication processes will go into avoid these kind of processes such as painting, sorry, polishing and finish machining. Okay, and also excessive tolerances, surface finish requirement, and so on are commonly found problems that results in higher than the necessary production costs. So when you are designing a product, so the tolerance what you will going to provide, it should be an optimum tolerances. Very carefully we have to design the components for its dimensional tolerances, and also unnecessarily providing the surface finishes. So if it is not, definitely it is not required, and unnecessarily you are just showing indicating the surface finish of so much is been required. So definitely it with the common problems, that's what they say, it are the common problems that results in the higher than the necessary production cost. And next, what they say, avoid separate fasteners. The use of fasteners increases the cost of the manufacturing a part due to the handling and feeding operations that, yeah, just 10 minutes I'll take, that have to be performed. Besides the high cost of the equipment required for them, these operations are not 100% successful, so they contribute to the reducing the overall manufacturing cost efficiency. In general, fasteners should be avoided and replaced, for example, by using tabs or snappets. The most important thing in reducing the manufacturing cost is to avoid the separate fasteners. See, if you are using the more number of fasteners, it always leads to increase in the cost of manufacture. So the reason for that is it will go into increases the handling and feeding operation. Okay, and besides of the highest cost equipment required for them, these operations are not 100% successful, so they contribute to reducing the overall manufacturing efficiency. This is another one important thing you should keep it in your mind. In general, fasteners should be avoided and replaced, for example using a tabs or snap fits. So you can see here, so screwing, riveting, plastic bending, and snap fit. See, from the snap fit, if you move towards the screwing, the cost will keep on increases. Select the most inexpensive fastening method required. Inexpensive fastening method required. Okay, so screwing, riveting, plastic bending, and snap fit. Or you can put it in the reverse order: snap fit, plastic bending, riveting, and screwing. So this will keep on increasing. See, the increasing the cost if you move from snap fit to the screwing. In the sense, if you use snap fit, you will have a lesser cost, and when you use the screwing, you will have a more cost. This is another one important thing. You should be very careful. And this is a general design principle, self-fastening features. So you can see here. So instead of using this, see, you can design in this way. Designing in this way, it will leads to the self-fastening features. So it will reduces the cost of the fastness. Okay. And next one is minimize the assembly directions. All parts should be assembled from one direction. If possible, the best way to add the parts is from above in the vertical direction parallel to the gravitational direction. Okay, in this way, the effects of gravity help the assembly process, contrary to having to compensate for its effect when other directions are chosen. Okay, so in the sense, when you are designing the parts or DFM, you are using DFMA. So please keep it in your mind that you can minimize assembly directions. So if all the parts can be assembled in only in single direction, that is the best possible way. Okay, so that you can start from the bottom one, you can go up. Okay, or you can go from top to the bottom. So again, in the parallel to the gravitational direction, from top to the bottom in the vertical direction, that is the best method always. And if you just design the components in such a way that it will definitely will affects the gravity, help the assembly process, contrary to compensate to for its effect when other directions are chosen. This is another one rule what we are having. So general design principles, look at here. So we're going to start from down to go like this. We're going to have top down assembly. We call it as a top down assembly for DFMA. And then we'll have a handling difficulties. See, size, thickness, weight, fragility, flexibility, slipperiness, stickiness. So this is another one important thing. See why? Because when you are designing for manufacturing and assembly, so you should keep it in your mind what the size of the component, what is the thickness of the component, what about its weight, what about its fragility, flexibility, slipperiness, stickiness, like that. So all these leads to the difficulty in handling the components. Okay. So see, this is here. The size is very small. It's very sharp, slippery. So it may just slip out of your hands when you are taking that part for any assembly purpose. And flexibility. So these are the things what should be very careful while you are selecting the parts for them. And ensure parts do not need to be held in position. In the sense, holding down and alignment required for later operation, self-location. Secure parts once they are assembled, spring, retaining access, chassis, projection. Assembly should be stable. See, this is secure the parts once they are assembled. It is very, very important from the assembly point of us. Okay, so we should assemble so that it should be very stable. Okay, that's all, my dear students, for today's class. Okay, so these are some of the guidelines that needs to be remembered. Okay, so while you are designing or DF, when you are implementing DFM or DFME, so these are the guidelines that needs to be followed and that needs to be implemented. Okay, so in tomorrow's class, I will be discussing the same concepts over there. Okay, so we will have some more discussions on the same topics tomorrow. Okay, so we will going to continue tomorrow. So if any clarification anywhere, you can ask me before we start winding the class. Any clarification, my dear students? Mithun, Sandesh.
No, sir.
So tomorrow also we will going to continue with the same thing. Okay. So I will going to put. So best get the information from your Kiran sir when you are having a technical seminar, and looking at that I will going to put the schedule for your presentations. Okay.
Okay. Yes, sir.
Thank you. Thank you for joining.
Thank you.